Good afternoon. This is Schweitzer. We're doing a little video here on the mathematics and formula derivation for throwing an object at an angle. Okay, so a couple things here that we really want to make sure we're taking a systematic approach to how we solve these problems. And whenever we're throwing something at an angle, keep in mind that we're always, first thing we do is time in the air. Okay, and you should be aware at this point, or becoming aware, that the x component has some functions and the y component has some functions. Now we're throwing this thing at an angle, okay? So when you throw something at an angle like this with a certain velocity at this angle, okay, it has a component that is in the x direction and it has a component that's in the y direction. Sometimes I call that velocity y and velocity x. All right, so the velocity in the x direction controls really only one thing, and that is how far down the range you get. So if you want to find maximum range or where you hit the ground on this thing, it controls this distance as to where you hit the ground. Okay. All right, so what does y tell us? Y is going to be pretty important. Y is going to tell us time in the air, and it's also going to tell us the maximum height. And sometimes that's a common question. Okay, so let's very first thing. The first sort of idea you're looking to encompass here is time in the air. But when I see a problem that's got an angle, all right, and it's got a velocity and like this, I'm always immediately, my mind says, okay, I need to know my components. So let's do that just quickly here, and I'm going to use our cosine sine functions. We've done this a couple times already. So what is here? It's going to be the magnitude, which is the velocity of the vector, times the sine of the angle. All right, will give me my y, the velocity in the y, and my velocity of the throw times the cosine of the angle will give me my velocity in the x direction. Okay, so I'm looking for time in the air. Okay, so there are, of course, two formulas that we're really looking for here, and this is going to be x. I'm going to use y here because just not a bad thing. Yt equals y initial plus VIT plus 1/2 AT squared. And we have velocity times t equals velocity initial plus AT. Okay. So we're finding the time in the air. Okay. It is sometimes nice to use this formula because we're going to use one more small property here that in the y component there is a initial velocity y going up, but as it goes up, gravity is sort of chewing on it a little bit, and right here in the y component, the velocity of the y, okay, equals 0. Now, if it's on flat ground, you could use this here and say, I want to know, okay, with all the stuff I have, I start out at 0, I'm going to end at 0. What time will it take to get back to 0? That's another option. And you could use it's a quadratic at this point. You need your velocity initial, and you'd have your right there. Okay, solve it out, and you'd have time. But for this one here, I'm going to go with this other guy, and it's going to be just simply here, Vt equals 0. So Vi, subtract it over Vi in the y direction, okay, is equal to, I'm going to divide out the acceleration of gravity equals the time I'm in the air. Now, this is time to go to the top. So this is 1/2 the time. So I would double this thing. So it's going to be -2, all right, y all right, that's my initial velocity, over acceleration of gravity equals the total time of the trip. I doubled it because the time up equals the time down. That's why I doubled it. Okay. Now let's take a moment here and put in this velocity. Took the v out there. It's v there. So let's plug in this value for the initial velocity of y. So it's going to be this guy here. It's going to be, so time equals -2, and doubling it, velocity of the throw times the sine of the angle. This component gives me that velocity of y divided by the acceleration of gravity. And this will give me my time in the air regardless. Okay? I'll have my initial velocity, I have my angle, and I have my acceleration. This is just g, gravity. Okay. This is, there we go. Okay, so we're going to use that. And our formulas now, they might get a little bit more complicated, but in reality, it's just plugging things in. And if we can do it with these formulas, then we can do it with numbers just as easy. So let's go with maximum height. Okay, so I'm looking for, now this is the total time in the air. When you do maximum height, typically speaking, you're looking for x or yt at 1/2 of your total time. I want to know my time when I'm at halfway through time-wise of my trip. And that would just be half of that. Okay, so t 1/2 would just be negative velocity sine of the angle divided by acceleration of gravity. I put a g there this time. And at that point, this is the time for 1/2. And then I want to locate my position. Okay, so let's just kind of plug and chug here. Might get a little bit hairy as far as some numbers here, but I'm looking for yt, location. All right, initial guy is 0. Velocity initial, okay? Velocity initial in the y direction is just this guy, right there. So it's going to be velocity times the sine of the angle, right, times the time it's in the air. The time I want is negative velocity sine of the angle divided by the acceleration of gravity. Right, that equals my time. Plus, okay, now I want 1/2 at squared. So it's going to be 1/2, so 1/2 acceleration of gravity, my time. And it's going to be time or half. This is going to be negative velocity sine of the angle divided by gravity. Okay, and there we go. Now, on an AP style problem, they just don't do this stuff. You know, it's something that when they ask you something, it literally will be kind of like this. But just so you know, this is perfectly good, and it would give us our answer. Okay. All right, let's plug in for maximum range. Okay. So maximum range is going to use the x component. All right, so the time in the air still is the same, and I want time the whole time it's the ground. Okay. So let's use the x component for max distance. Xt equals xi plus vit plus 1/2 at squared. Now, in this situation, a couple things you want to recognize. Really important stuff. Gravity only acts in the y direction, so there's no acceleration in the x. This is what we get. Xt equals xi, which is 0, so it's just velocity initial. The velocity initial is velocity of the vector times the cosine of the angle. Okay, cosine of the angle, and then times time. Well, time is right here, -2 times the velocity vector of the sine of the angle divided by the acceleration of gravity, and there we go. Okay. And we have now a formula for the location of maximum range. Okay, 3 different formulas. And I'm not saying that the problems you see on tests and quizzes will be problems we've seen before, and they'll be pretty straightforward. But let's go to, so this is just using the math and solving things out. So let's try an actual problem with some numbers, okay? So a ball is thrown at 20 degrees at 10 and 40 degrees, so a little steeper at 5. Which ball goes higher? Which ball goes longer? Which ball lands the farthest away? Okay. So first thing that we want to know is I'm gonna solve for, let's say, which ball goes the highest first. Let's try that one first here. Okay. Now notice I doubled my velocity. Here I doubled my angle. Okay. So let's go ahead and solve for one of our first things we have here is time in the air. Time in the air. And I'm going to use the fact that it goes to, let's go in fact highest ball, let's go 1/2 time. You can do that pretty easily. Okay, so again, it's the y component. All right, so let's take our angle, and let's just do A here for a second. All right, so the scenario A says I got 20 degrees, so I got a 20-degree ball here thrown at 10 meters per second. So it's going to be the sine, the 10 times the sine of 20 and 10 times the cosine of 20. And this is something that I would do pretty quickly as I'm getting started. 10 times the sine of 20 equals 3.4. And 10 times the cosine of 20 equals 9.39. 9.39. 9.39. Okay, we get that. And it is going to be in meters per second. Meters per second. Okay. And that's okay. Well, what's the time for this thing? We know that VF is 0 at the top equals VI plus AT. I want the time for this to be at 0. So it's going to be negative, subtract over VI, divided by A equals my T. Now this is going to literally just give me the time for velocity to get 0, which is at the top. This is T 1/2. Okay, so velocity initial. I'm looking only in the y component, which is going to be this guy. So it's going to be 3.4 negative divided by the negative 9.8, because we're not going to get a negative time, and I get my time here. Negative 3.4 divided by negative 9.8, and we get 0.34 seconds. Notice I just used this formula right here. For half the height would be right here. Velocity sine over g. Just use that formula. Okay. And really this whole page would be now just literally, you could hire a 5th grader to do it for you because they can plug stuff in calculators. And they wouldn't know what's going on. But if you're the engineer on site or the one in charge and you've got all the stuff figured out, you could just have someone else do the manual labor for you. So which ball goes higher? So let's just take our formula here, and I'm just going to grab that. What was that again? To do the other one with the formula. So just negative v sine of angle over g. Okay, got that. So it's going to be negative v sine of the angle over g. All right, and let's plug it in here. So I got negative velocity, which is this guy is going 5 times the sine of 40 degrees divided by negative 9.8, and I get 0.32 seconds. Okay, so 0.327. So I just took this guy here I took the 5 times the sine of the 40 degrees over negative 9.8, and this gave me 0.32 seconds. So, did which ball goes higher? Okay, well I haven't solved. I guess got time. Okay, and I could have just plugged it in. Let's do that next. Okay, a little bit different times. So this guy here is going to be which ball high max height. Okay, so I'm looking for yt equals y initial plus vi t plus 1/2 at squared. Okay. Now again, this might be a little bit more difficult. Well, a little bit, maybe this might be an example where this formula right here becomes a little bit cumbersome, where you got to do all this stuff. This would be nice in a little computer program where you can just plug values in and it just automatically did it for you. But it's going to be just as easy here. So we got yi is 0. Velocity initial is just going to be, in the y component, is 3.4. The time is 0.34 seconds. All right, plus 1/2 acceleration of gravity, negative 9.8. And then my time is 0.34 squared. Take a moment to calculate that. Now, when I solve these problems out, just so you know, I mean, not everyone's in the same place mathematically. So I combine these vectors in two little factors. Get me a number here, get me a number here. This number, because of the negative, will always be negative. Okay? So 0.34 squared is 0.115 times, I might not even put the negative on there, 0.98, 9.8 times 0.5, but I know it's negative, so I'm going to go, this is a negative 0.566, and I got this guy, 3.4 times 0.34. Alright, so we got here, we have the initial velocity and my time, okay, enter, 1.156, 1.156, plus the negative 0.563, and we get 0.593. So there's a little bit of rounding difference here. Typically this might be double this one. But my new height is about 0.593 meters. Okay. And you can plug the same thing in for the other guy. Okay. So this guy does have a larger y component. He's in the air less time. It goes higher. Okay. In this situation, we got, all right, so we got here time in the air 0.32, so it's going to be yt equals, okay, 0. Initial velocity is going to be the, I didn't do this one yet, so let's just plug it in here. It's going to be the 5 times the sine of the angle, which is 40 degrees, okay, nice, times time in the air, which is this guy there, which is 0.32, 0.32, okay, plus 1/2, negative 9.8, okay, and then we're going to look at the acceleration of gravity to that, and I just need time squared, which is the 0.32 squared, okay. All right, let's put all this number together here. I got 0.32 squared, so it's in the air just a shade less, times negative 9.8 times 0.5 is negative 0.5. Okay, it's negative 0.5. And let's solve this guy out here. Okay, so it's going to be the sine of 40 gave me 0.62 times 5, which is its velocity, times the time, which is 0.32, gave me 1.02. 1.02 minus the 0.5 is just 0.5, so 0.52 meters. Okay, so yt equals 0.52 meters, and it's still just a shade less. Okay, so all right, so that's a good interesting questions. Which ball goes higher? That's I think where we'll end this page here. Which one is near the longest? We did that right here, both real close. There's not a big difference here in velocities, but which ball lands the farthest away? And of course, you can solve that problem out. We're going to skip that one for now because it's getting long enough. And here's your practice question. Okay. Again, I think I'm not going to do this problem. Well, let's see. I'll put this one in the next video. Okay. This is a little bit of a different style question here, so it's a little challenge question. So, all right. Thank you very much.